Okay guys, I gave you a worksheet for Hess's Law, and I'm just going to work through these examples that I gave you so that you can check your work. This is example number 1, and remember that Hess's Law states that the delta H, or the heat of reaction, or the enthalpy of a reaction, is the same no matter if you do that reaction in 1 step, or if you do it in 2 steps, or if you do it in 3 or 4 or 5. Your total delta H is always going to be the same. So for this one, we have a reaction of carbon plus oxygen, which is a simple combustion reaction, gives you carbon dioxide. And down here, we have this reaction that's taking place in 2 steps. So we're going to work through this, and using the given values for delta H that we have for the 2 steps, we're going to calculate what the total delta H is. So this first example is really simple. I go through and I look at my 1-step reaction, and I pick out everything from that reaction and find it in my other reactions. So we're going to start with solid carbon on the reactant side. And so we go down here and we find solid carbon in this first one. And it is also on the reactant side, so we don't have to change anything yet. Then the second reactant is oxygen. So we go down here, we find oxygen right here, and we find oxygen right here. And both of those are on the reactant side also. So that means we don't have to reverse anything or change anything yet. And then our final product is carbon dioxide. And so we find carbon dioxide here, and they're both on the product side. So that tells us that we don't have to reverse either of these 2 reactions to work this problem. So what we really need to do then is just look at our reactants, look at our products, and see if there's anything extra that we don't need and get rid of it. So we have carbon monoxide here, and we have carbon monoxide here. So one is on the product side, one is on the reactant side, so they're kind of like the spectator ions that we did in the ionic equations. You just cross them out. So now we just take our reactants that we have left, which is solid carbon plus 1/2 oxygen plus 1/2 oxygen yields carbon dioxide. Okay. The 1/2 oxygen and the 1/2 oxygen added together make a whole oxygen, so we end up with solid carbon plus oxygen, which is gas. I didn't put it up here, but you know that it is. And then carbon dioxide, which is also gas. Okay, so we have solid carbon, oxygen, oxygen, carbon dioxide. We have taken these 2 reactions and added them together to get our original problem. So what that tells us is we didn't have to reverse anything, we didn't have to double anything or half anything or change anything like that. So we can use these 2 delta H's just as they are and add them together. So we take negative 110.5 plus negative 283.0. Add these up, and you get 393. And don't forget your negative sign, because this is a negative 110 plus a negative 283 gives you negative 393 kilojoules. And that's your final answer. That's an exothermic reaction.